Okay, let's dive into this. Welcome to today's explainer. If you're a middle schooler trying to wrap your head around algebra, you have absolutely come to the right place. Consider this your ultimate, foolproof study guide to cracking a mathematical mystery. Today we're going to decode the secret language of numbers by looking at something you've probably played on since you were a little kid.
Here's our roadmap for today's study guide. We're investigating 5 main clues. First, the playground seesaw mystery. Second, what is mathematical balance? Third, the golden rule of algebra. Fourth, balance in everyday life. And finally, a final practice problem quiz. By following these clues, we are going to solve the case of the unknown variable.
Let's start with section 1, the playground seesaw mystery, a physical experience. We're going to take a really abstract idea, algebra, and anchor it to a physical experience we all know. So have you ever sat on a perfectly level seesaw? Picture it in your mind. You're sitting on one side and your friend is sitting on the other. Neither of you has your feet touching the ground, but you aren't moving up or down either. You just sort of hover there, suspended in midair, because both of you weigh exactly the same. You both stay completely level. That perfectly flat, motionless state, that is balance. And here's the crazy secret we're exploring today. That physical balance you feel on a playground is actually the hidden rule of all math. Moving right along to section 2. What is mathematical balance translating to numbers? Now that we have our playground clue, it's time to translate that physical feeling into actual numbers. An equation is simply a statement that two things are equal. I want you to think of the word equation as our primary magnifying glass for this whole mystery. Whenever you see an equation in your math homework, it's just a clear, simple statement telling you that the left side and the right side must carry the exact same weight. Nothing more, nothing less. Imagine an old-fashioned balance scale, the kind with two metal pans hanging from a central beam. On the left side, represented here by the blue text, we place a solid 1 kilogram iron weight. On the right side, the red text, we place a bag of sugar. When that scale becomes perfectly level, just like you and your friend on the seesaw, you know without a shadow of a doubt that the sugar also weighs exactly 1 kilogram. It has to be the exact same weight on both sides. Let's look at our first practice problem and apply this to numbers. On our blue left side, we have 3 plus 4. On our red right side, we have a 7. Does 3 plus 4 perfectly level out with 7? Yes, it absolutely does. 7 equals 7. Just like the physical iron weight and the bag of sugar, the numbers on the left perfectly balance out the numbers on the right. Section 3, the golden rule of algebra, solving the mystery. Now we get to the core detective mechanic for uncovering the true identity of the unknown variable, usually called x. Here is our second practice problem, but, this time it's an unbalanced seesaw. On our blue left side, we have an unknown mystery weight x, plus 2. On the red right side, we have a heavy 5. Right now, this seesaw is tilted all the way down on the right. The red side is heavier because 5 is heavier than our current mystery setup. Our job as math detectives is to figure out what x needs to be to level this whole contraption out. Now, what's really interesting about this is how the seesaw instantly levels out the second we reveal the true identity of x. To make the blue side equal to the red side's 5, x must be 3. Why? Because 3 plus 2 equals 5. The missing weight is 3, and boom, the seesaw is perfectly level again. The equation is solved. So, the absolutely crucial point is this. Whatever you do to one side, you must do to the other. This is the golden rule of algebra. It's the absolute unbreakable law of the mathematical playground. If you decide to subtract 3 from the blue side to isolate your variable, you must subtract 3 from the red side. If you add 50 to the right, you've got to add 50 to the left. If you don't follow this rule, your seesaw crashes heavily to the ground and your equation is wrong. You have to keep it balanced. Let's shift over to section 4, balance in everyday life, beyond the classroom. Because it's super important to see how this tool isn't just stuck in a textbook. It's used everywhere outside the classroom. You are actually using algebraic balance every single day without even realizing it. In professional cooking, chefs use kitchen scales to perfectly balance flour and sugar to bake the perfect cake. Careers in culinary arts, and even things like structural engineering, rely entirely on this principle. Or think about carrying heavy shopping bags. If your bag is heavier on one side, your shoulder starts to ache. So what do? You equalize the weight. You move items from one hand to the other to balance it out. Even in video games, your character's health and mana bars often need to be perfectly balanced for the best survival strategy. Balance isn't just math. It's comfort, it's fairness, and it's success. And that brings us perfectly to section 5, final practice problem quiz, test your skills.
Welcome to the final stage of our explainer. Let's put your detective skills to the test. Here is your third and final practice problem. Consider this your summary pop quiz. Read the question carefully. If the blue left side of our seesaw is x plus 4 and the red right side is 10, what must x be to perfectly balance the seesaw? Think back to our golden rule. How do we make the blue side weigh exactly 10 so it equals the red side? I'll give you a second to solve the mystery of this missing weight in your head.
Did you get it? The answer is a giant 6. 6 plus 4 equals 10. By figuring out that x is 6, you have successfully closed the case of the missing weight. You've completely solidified the single most important concept in algebra, keeping both sides equal.
As we wrap up this explainer, I want to leave you with a pretty wild thought. What would actually happen if mathematical balance just stopped existing? Without it, towering buildings would collapse, professional recipes would taste terrible, and everything in our structured world would simply tip over. Balance is what makes things work. Coming up next in our study guide series, we have C as for circumference, how a bike wheel measures the world. You really won't want to miss it. Until then, keep your equations perfectly balanced.